Composite shapes are shapes that are made up of more than one figure. So we've been learning about cones, spheres, and cylinders, and the following composite figures we're going to look at may have a combination of those that we need to use to find the volume of the given figure. So for example, if we look at the image given, it is not just one of the shapes we've been looking at. So you need to identify the formulas you need based on the shapes we have. So if we look at the image here, this top part we can see is a cone. So we know we need the volume formula for a cone. And then we can see this bottom part here is actually a little cylinder. So we need the volume formula of a cylinder. And those combined are going to give us the volume for this overall shape. So because this isn't anything too new, I'm going to let you go ahead, find the volume of the cylinder part, find the volume of the cone, and then hopefully you realize to find the volume of the entire shape, we would need to add those volumes together. So go ahead, pause the video, and give it a try first. So in the cylinder, we can see that our radius is 5 and our height is 2. Height is 2, radius is 5 of the cylinder. So that gives me our volume to be 157 cubic centimeters. Our cone, our radius is 5 and our height is 12. Okay, so realize here you had to do the Pythagorean theorem to find out what that height was. So that's how I got 12, which gives you 314.2 cubic centimeters for the volume of the cylinder. And so then we're going to take the volume of the cylinder, the volume of the cone, to equal 471.3 cubic centimeters. All right, so again, first thing we need to do is identify which shapes we have. So we can see that we've got a cylinder here, and we've actually only got half a sphere, so we call this a hemisphere. So to calculate the volume for this portion, we actually need to calculate the volume for a full sphere and then cut it in half. So go ahead and give this one a try. Alright, so the cylinder, our radius is 6, right, because I was given the diameter, so your radius is 6, your height is 13, so that gives you your volume here to be in cubic inches. Now remember, first we need to find our whole sphere, so our radius being 6. Then once we have the volume for our sphere, we need to cut that in half, because we only have half a sphere, called the hemisphere, to give us our volume for the hemisphere. Take those two volumes, add them together, and we get our final answer. Alright, so I'm going to let you identify what shapes you have here and do this one completely on your own. Go ahead and give this one a try. So we see we have a cone here. So our radius is 3 and this is our height. Right, instead of labeling it right here, that is the same distance over here. So our height is 6. And then for this is a hemisphere again, it's only half of a sphere. So first we have to find the volume for the full sphere, radius being 3. Divide that by 2 to get a hemisphere. Then we're going to take those two volumes, add them together to get our total composite volume. So oftentimes in composite figures, we will often see a rectangular box, also known as a rectangular prism. We've seen them earlier this year when we were learning about the Pythagorean theorem. However, you haven't learned how to find the volume of it, but it's really simple. So I'm just going to give you a hint that the volume for a rectangular prism is length times width times height. Oops, height. So you just take the three measurements of the rectangular prism and multiply them together, and that gives you the volume. Okay? So find the composite volume of this shape. So rectangular prism, 9 times 4 times 5, should be 180. The other shape we had was a cylinder, so make sure you use the right formula. Radius being 2, height being 3. Take those two volumes, add them together to get our composite volume. All right, last one. So a soccer ball is packaged in a cube box. So again, there's that box, that rectangular prism formula we just talked about on that last problem you're going to have to use here again. I want to know, what is the space in the package not occupied by the ball? Not occupied by the ball. So I want all that free space in the box. So think about this while you are solving this problem. Go ahead and give it a try. So the box, or the rectangular prism, 20 times 20 times 20 gives us our volume there. We have a full sphere, so we don't have to divide by 2 this time, radius being 10. However, instead of adding these volumes, because I want to find the space left over, not occupied by the ball, I have to take the volume of the box, take away the volume of the ball to see what is left. And that is my answer.